How we doing? This is Matt Hank, and I'm going to follow up on our second video series regarding precision form training and some of the information that I've been discussing and learning from Dr. Vera over the last year or two. So if you go back to our first video, we talked a little bit about the bubble cheek and specifically some of the new parameters to start to investigate, such as CoP, which was center of pressure, right? Our example was that BOSU ball and the pinpoint accuracy on the ground of the BOSU ball. We looked at ASP, athletic spine performance, and we talked about the spine and the coil of the spine. And then we also looked at breath and that forced inhale and exhale. So why do we talk about these variables? Because they can directly influence power, right? For power production, being more explosive. But one thing we want to do today is look at the connection between power development and the voice. So we're going to look into this idea of the brain-body voice, or the brain-body glottis, over the next few minutes. Okay, so let's start to look at practical application of why the voice matters. Most of us in the performance field have heard of the Valsalva maneuver, and the idea specifically, say with powerlifting techniques, you're squatting, you would take a big breath in. This is what's taught in most textbooks, most weight rooms, and clamp down, and then perform your movement, squat, bench press, etc. But what we're going to do is we're going to look at how the Valsalva maneuver can be manipulated with this term, an open glottis. So we're going to look at specifically first these two parameters of our equation to dissect the Valsalva maneuver. Okay, the new term that we're going to investigate today is subglottal pressure. And what we're looking at is pressure below the glottis. So what is the glottis? That's the space between the vocal cords. So when you breathe in, right, the space between the vocal cords, your glottis would open. So in this case, let's just show it vertically, it would open. And our example for the Valsalva maneuver with the closed glottis, right, when we do squats, especially powerlifting movements that we're taught in the weight room, to clamp down. Right, but we can also now introduce Valsalva maneuver with an open glottis, in which case you can have manipulation or posturing of the vocal cords. So that breath can have continual flow through the vocal mechanism. Okay, so let's now make the connection between the subglottal pressure and ASP, athletic spine performance. Again, going back to our Valsalva maneuver with a closed glottis, why are strength coaches implementing this? Well, they're looking to protect their lumbar spine. So that's where they're focusing on. They're focusing on that intra-abdominal pressure. However, we're missing the thoracic through the cervical spine. And specifically, the cervical spine is where the glottis is housed. So one thing that we should start to look on is the full coil of the spine instead of this idea of a closed Valsalva maneuver, which is really that lumbar spine isolated. So we're trying to flip things around and now look at the entire coil of our spine and performance of our spine with an open Valsalva maneuver. Okay, the last parameter that we're going to look at is CoP, right, or center of pressure, as it's related to the proprioceptive system. And specifically, we're also going to look at how the vocal mechanism is an example of fine motor control, similar to our fingers, our eyes. And when we tie things back together, which makes things groundbreaking and revolutionary here, is we have our center of pressure with fine motor control, ASP with our coiled spine, our lengthened spine, breath with our subglottal pressure. So we're optimizing fine motor control, but we're able to do that at the same time that we're enhancing power and generating explosive movement.